Hi guys, in this video we're going to work through some written answer questions together on amount of substance. This first question, calcium phosphate reacts with aqueous nitric acid to produce phosphoric acid and calcium nitrate as shown in the equation. We've got a mass of calcium phosphate and it's reacted completely when added to excess nitric acid to form 38 centimeters cubed of solution. And it's asking us to calculate a concentration of phosphoric acid to three significant figures. So a good place to start is the calcium phosphate. We're given a mass of this so we can calculate the molar mass using the periodic table. So use the big numbers from the periodic table and add them up for each element. And then we can calculate moles of this calcium phosphate by doing mass over mR. And we get this number of moles. The next thing we do, the question is asking about phosphoric acid, so we need to use the balanced equation and take into account the stoichiometry or the molar ratios. So we've got one lot of this calcium phosphate and two lots of this phosphoric acid. It's a 1:2 ratio. That means that the moles of phosphoric acid are double that of the calcium phosphate. So we can calculate the moles of the acid. We simply double the moles that we got for the calcium phosphate. Then we're on the final step. We can calculate the concentration of the acid now by doing moles over volume. The moles we just calculated over the volume converted into decimeters cubed. And we get 1.23 moles per decimeter cubed. Here we've got a question where we have to write a balanced chemical equation, and that relies on us knowing our formulae. So calcium's a group 2 metal, hydroxide is OH-, we've got a 2+ and a 1-, so we need two lots of the hydroxide. We put that in brackets because we need two of the oxygen and hydrogen. And then calcium phosphate, to get the formula of that, phosphate is 3-, calcium's 2+, so we swap and drop the charges, or you can think of it like we need 6+ and 6- to make those charges cancel out. To balance, first thing I balanced was the calcium. We've got 3 on the right hand side, so I put a big 3 here. Next I looked at the 2 phosphorus on the right hand side, so I put a big 2 there. And then I added up the hydrogens, 6 + 6, that's 12, and we've got 12 on the right. Calcium's 3 and 3, phosphorus 2 and 2, oxygens 6 + 8, and here 6 + 8, so we're balanced. Next question is a hydrated salt question. A student heated 4.38 grams of hydrated zinc sulfate. That means it has water molecules that are bonded to it and part of that crystal structure. So they heated that and they obtained 2.46 grams of anhydrous zinc sulfate. So in other words, they heated and drove the water off. Use this data to calculate the value of X. Okay, so the first thing we do is subtract these two masses to get the mass of water. 4.38 minus 2.46, and we get 1.92 grams of water. Next, we can calculate the moles of zinc sulfate, the anhydrous salt, and we use the mass that we're given over the molar mass. So moles equals mass over molar mass. And then we can calculate the moles of water. So we're going to use the mass of water that we calculated from this difference over the molar mass of water to get the moles, and then the ratio of moles of water to the anhydrous salt gives us X. It tells us how many waters are in that formula. And we do big number over little number to get the number of waters. Next question, we need to use two different moles equations. We've got an amount in moles of zinc oxide and a concentration and a volume of acid, and it's asking us to calculate the mass of zinc chloride that can be obtained. So the word maximum doesn't really matter, we can ignore that, it's just the mass. First step, we can use the concentration and volume to calculate moles of the acid. Remember to convert the volume into decimeters cubed by dividing by 1000. We get the moles of the acid, then we can use the ratio in the balanced chemical equation. We've got 1 lot of the zinc oxide, 2 lots of the acid, so that means that the moles of the zinc oxide will be half that of the moles of the acid. And then finally we can calculate our mass of zinc oxide by rearranging that moles equation and doing moles times molar mass of zinc oxide.